Welcome back for lesson 24-1, where we're going to be talking about how to solve exponential equations. So today we're starting with the first type of equation we're going to see is when we can solve them using similar bases. So we have a note sheet for today's video. Make sure you have something to write with, a calculator to help you solve. Then you're also going to want the root chart that I posted in Google Classroom. Okay, so the root chart looks like this. Let me zoom out so we can see it all on one kind of screen here. And I posted this in the class materials in Google Classroom, so we can use it for multiple sections. But all the root chart does is help you see which numbers basically have the same base. So your bases are going to be all the numbers in bold. Okay. So your well, if we have like 9, for example, it's going to have base 3. Okay, 216, that's base 6. Okay, and so on and so forth. So we're going to use this root chart. If you're not so good with your factors, use this to help you figure out how to get that same base. So let me talk about what I mean by that. Okay, an exponential equation is an equation in which the variable is in the exponent spot. So looking at the example here that I stole from your book, 4 to the x power, okay, your variable is in the exponent spot. Okay, sometimes you can solve an exponential equation by writing both sides of the equation using the same base. Okay, so see, this is base 4 to the x power. Okay, we want the bases to be the same, so we can use this kind of property that we have here. Okay, that when we have the bases the same in an exponential equation, bm equal to bn, if our bases are the same, that means our exponents are the same. So we can set if our bases are equal, we can set our exponents equal to each other. Okay, so let's look at this example A really quick, talk through it, and then we'll do some on our own on the bottom here. So the problem is 6 times 4 to the x power is equal to 96. Okay, now their first step said to divide both sides by 6. And that's because you always want to isolate your exponential first. So meaning this 4 to the x power, I need him by himself. So divide the 6 out on both sides. And now we have this expression. Okay, 4 to the x power is equal to 16. Now 16 doesn't have a base of 4 right now. So we're going to rewrite 16. This is where the root chart's going to come in. Okay, as base 4. So you see how 16 is a power of 4, so we can write them as the same base. Now 16 is 4 squared. So I'm going to rewrite 16 as 4 to the second power. So now that we have the bases the same, 4 and 4, we can set their exponents equal and solve for x. Okay, so x is 2. So let me show what I mean on a couple of examples down here. In A, we have 2 to the 2x power is equal to 2 to the 6th power. Now, as you can see, your bases are already the same in both of these. 2 to some power, 2 to some power. So according to our property, if our bases are equal, we can set our exponents equal to each other. So we drop the bases and just bring down your powers. 2x is equal to 6. Now, this is pretty easy to solve after that. We would just have to divide by 2 and get that x is 3. Okay, so let's look at example B. Okay, I said you always want to isolate your exponential first, so I'm going to add this 1 to the other side. So we have 3 to the x power is equal to 81. Okay, right now we do not have the same base. We have 3 and 81. So this 3 to the x I'm going to keep. Okay, but I need to rewrite 81 to be a base 3 equation. Okay, so going back to that root chart, if we need it to be base 3, I'm going to look in this line of 3s here. Okay, and you can see I found 81. Here it is. So 81 would be 3 to the 4th power. So we're going to rewrite 81 as 3 to the 4th power. So 3 to the 4th power is 81. They're the same exact number. They just look a little different. Okay, now that our bases are the same, we can set our exponents equal. So we can drop the bases. And this one solves itself. X is 4. Okay, let's do another one. Let's look at C. We have 2 to the x power is equal to 1 over 32. Now we're going to talk about how to rewrite this, but we're going to keep this 2 to the x power I need to rewrite this fraction as base 2. So this has to be 2 to some power. So let's see. If we have 1 over 32, let's go back to our root chart. So we're base 2, so I'm looking in this row. Oh, well, there's 32. So 32 is 2 to the 5th power. So we're going to rewrite this fraction. It'd be 2 to the 5th power. Now that's good for this, but we don't want it as a fraction. We need 2 to be a whole number, like the big base. Okay. So in order to move that 2 to the top, we have to remember some exponent properties. Anytime we hop the fraction bar, it changes the sign of your power. So in order to move this 2 to the numerator, I would have to make this 2. I'd have to change the sign of my exponent. So 2 to the negative 5th. Okay, so just remember, you don't have to know all the process of it. Just remember, anytime you have a fraction, bump that fraction to the top and change your exponent to negative. Okay. Now I have the same base, 2 and 2, so I can set my exponents equal to each other. X equals negative 5. Okay, let's look at 2 more together, and then you guys are going to try a couple. So D, I have 4 to the x power equal 2 to the x minus 3 power. So 2 is going to be my base, okay, because that's the smaller number. Always use the smaller number for your base. So 2 to the x minus 3 is not going to change. But I need to change this 4 to become base 2. So again, back to my root chart. 4 is 2 to the 2nd power. So I can rewrite 4 as 2 squared. Now, whatever I change my exponent to, you have to multiply it by what is there first. So x was there first. 2 is my new power, so it becomes 2 times x. Now that my bases are the same, I can drop the bases and equal my power. So 2x is equal to x minus 3. We have variables on both sides here, so I'm going to subtract this x to the left side. So 2x minus x would be 1x. We have negative 3 left on this side, and that is solved for us. So the solving part that we're doing is not hard. It's just knowing how to kind of set up the equation. That takes some work. So I'm going to show you one last one in E. We have 6 to the 3x minus 4 power is equal to 36 to the x plus 1 power. So again, I can't equal my exponents until my bases are the same. So right now we have base 6 and base 36. So we're going to keep the smaller number. We're going to keep 6. So 6 to the 3x minus 4 power is not going to change. But I need to change 36 to be a base 6 problem. So going back to my root chart, looking at the row for 6, okay, there's 36. So 36 would be 6 to the 2nd power. So we're going to change this to be 6 to the 2nd power. Now, like I said before, take your new exponent and multiply it by what was there first. So I'm going to take this new 2 and multiply it by the x plus 1 that was already there. Okay, now we have it set up. We have the same base. So if our bases are the same, I can equal my exponents. So 3x minus 4, set that equal to 2 times x plus 1. And now we just solve this linear equation. So I'm going to go ahead and distribute that. So 3x minus 4. 2 times x plus 1 is 2x plus 2. And now let's get our variables on one side. So I'm going to subtract the 2x over. It's going to give me 1x. Okay, I'm going to add my constants to the right side. So I'm going to add the 4 over. So 2 plus 4 is 6. And then this problem is done. We have x equals 6. Okay, now the little math tip from above here, you can always take your answer and substitute it in and make sure you get something that is equal on both sides if you're unsure. But as long as you have the same base, okay, if your bases are the same, your exponents are the same. So once you get equal bases, you can drop the bases and just focus on equaling the powers and solving for x. Okay, so I'm going to have you guys try 2 problems on your own. So let's start with number 1. Okay, we have 5 to the x plus 1 power equal to 25. So 5 is going to be your base. you need to rewrite 25 as a power of 5. So use the root chart if you need to. What can you change 25 into? Okay, and use that to solve for x. So go ahead and try this problem. Okay, I got that x was 1. So let me show you my work. I changed 25 to 5 squared. Once my bases are the same, okay, I just equal my exponents. So x plus 1 is equal to 2. Subtract 1, you get x equals 1. All right, try one more. You have 2 to the 10x power is equal to 32. So your base is 2. Look in this row here. There's 32. So you can rewrite 32 as a power of 2. So go ahead and change that problem so that they have the same base, and then solve for x. Okay, I got that x was 1/2. So here's my work. So I changed 32 to 2 to the 5th power. So that means we can set 10x, since we have the same base now. Set your exponents equal, so 10x equal to 5. If we divide both sides by 10, you get 5 over 10, which would reduce to 1/2. Okay. So that is our first lesson on solving exponential equations. So again, the point is to get your bases to be the same so you can equal the powers.